Out in the vast, silent theatre of space, there are wonders that challenge our very understanding of how the universe works. We look up at the night sky, a velvet curtain sprinkled with distant points of light, and we imagine we have a sense of it all. But every so often our telescopes peer into a corner of the cosmos and find something so utterly strange, so bewilderingly beautiful, that it forces us to pause and reconsider everything we thought we knew. One such object, a celestial enigma floating in the constellation Serpens Kaput, has been doing just that for decades. It is a cosmic question mark, a puzzle box with no apparent key, known to us simply as Hoag's object. Imagine stumbling upon a perfectly formed diamond ring lying on a vast empty beach. You would naturally wonder how it got there, who made it, what is its story. This is precisely the feeling astronomers had when they first laid eyes on this galaxy. So, what is it that makes this galaxy so very unusual? To put it simply, it is its shape. Hoag's object is what we call a ring galaxy, but it is a particularly perfect and peculiar example of one. At its heart lies a bright, dense core, a nearly perfect sphere composed of older yellowish stars. They are ancient suns, having burned for billions of years, huddled together in a tight, glowing ball. This core is itself quite massive, a substantial galaxy in its own right. But it is what surrounds this core that truly captures the imagination and baffles the scientific community. There is a vast dark gap, an ocean of seemingly empty space separating the core from what lies beyond. Encircling this central sphere, across that great void, is a breathtakingly perfect ring. This outer ring is a vibrant, brilliant blue, a stark contrast to the old yellow core. To truly appreciate just how strange Hoag's object is, we must first understand what a normal galaxy looks like. For over a century, astronomers have been mapping the heavens, cataloguing the great islands of stars that populate the universe. Through this immense effort, we have learned that galaxies, much like living creatures, tend to fall into a few common categories of form and structure. The great majority of the galaxies we see, perhaps more than 2/3 of them, are spiral galaxies. Our own Milky Way is a wonderful example. They possess a bright central bulge from which elegant sweeping arms of stars, gas and dust spiral outwards. These spiral arms are dynamic places, much like the ring of Hoag's object. The other major family of galaxies is the ellipticals. Unlike the flat spinning disks of spirals, elliptical galaxies are more three-dimensional, appearing as giant fuzzy balls or elongated ovals of stars. Naturally, when faced with such a profound puzzle, scientists have put forth several ideas to try and explain how Hoag's object came to be. The most common explanation for the formation of ring galaxies involves a dramatic and violent event, a galactic collision. The theory goes that a smaller galaxy, perhaps a compact dwarf galaxy, plunged directly through the center of a larger disc-shaped galaxy. This cosmic bullseye would not destroy the larger galaxy, but rather send a powerful ripple, a density wave, expanding outwards through its disk, much like the ripple created when a stone is tossed into a still pond. This expanding wave would compress the gas and dust in the disk, triggering a massive burst of star formation as it travelled. This would create the bright blue ring we see today. Astronomers have searched the area around Hoag's object with our most powerful telescopes, scouring the darkness for any sign of this interloper galaxy, and they have found nothing. But these are explanations born of desperation, attempts to salvage a theory that simply doesn't quite fit the evidence. The difficulty in explaining its formation has led some astronomers to label Hoag's object a galaxy without a discernible past. Its present state is so perfect, so pristine, that it seems to have erased all clues of its own violent or gradual creation. If it was formed by a collision, the evidence has vanished completely. If it formed through slow accretion, the process is unlike any other we have modelled. It's almost as if the galaxy simply appeared in its current form, which honestly runs contrary to everything we know about cosmology. The universe builds, it does not simply conjure. The great astronomer Carl Sagan often spoke of the cosmos as a place of elegant connections, where laws of physics weave the simple into the complex. But Hoag's object seems to defy this elegance. Its core and its ring appear almost disconnected. While Hoag's object is perhaps the most famous and perfect example, it's not entirely alone in the universe. Ring galaxies do exist, but they are exceptionally rare. It's estimated that they make up less than 1/10 of 1% of all known galaxies. A classic example is the Cartwheel Galaxy. Like Hoag's object, it has a bright ring of star formation, but there the similarities end. The Cartwheel's ring is warped and chaotic, its core is a mess. Faint spokes of gas and dust connect the ring to the center, clear remnants of the gravitational disruption caused by a collision. When we place Hoag's object side by side with its galactic brethren, its uniqueness becomes even more pronounced. Let us consider our own home, the Milky Way. It's a barred spiral galaxy, a bustling metropolis of somewhere between 200 and 400 billion stars. Our Sun is located in one of its spiral arms, the Orion Arm, about 27,000 light-years from the galactic center. Our galaxy is a place of constant motion and evolution, stars being born in its arms and dying in spectacular supernovae. It has a clear structure, a history we can piece together, and a future we can predict. It is complex, but it is understandable. Now, look again at Hoag's object. Its core of old yellow stars is reminiscent of a small elliptical galaxy. It's quiet, settled, and seemingly ancient. If this core existed on its own, we would classify it as such and think little more of it. But then there is the ring. This ring, full of young blue stars, behaves like the star-forming disk of a spiral galaxy, but without the arms or the central bulge to connect it to. It's as if an elliptical galaxy and the star-forming part of a spiral galaxy were placed in the same location, but kept separate by an invisible force field. This comparison highlights the central paradox. It does not conform. It stands as a solitary monument to a cosmic process that we simply do not yet have the language or the theory to describe. In the end, Hoag's object remains one of the most beautiful and stubborn mysteries in modern astronomy. It's a portrait of cosmic elegance, a perfect circle drawn in the ink of young blue stars, hanging in the void of space. It challenges our neat and tidy classifications. It reminds us that the universe is not obliged to make sense to us. Perhaps one day, with more advanced telescopes like the James Webb Space Telescope, we'll be able to probe the faint light within the gap, or measure the motions of the stars with enough precision to unravel its history. Maybe we'll find the faint ghost of an intruder galaxy, or discover evidence for a completely new mechanism of galaxy formation. But for now, the mystery endures, and that is valuable. The search for answers drives science forward. It's the unknown that fuels our curiosity. Objects like this are precious. They are guideposts pointing the way to new discoveries. They remind us that so much wonder remains. They keep us humble. They keep us looking up. The silence of space is filled with beautiful questions, and we are privileged to listen. The universe is a book of endless pages. We've only begun the first chapter. Hoag's object is a single illuminated sentence on a page we haven't reached. Its silent, shimmering ring is an open invitation to wonder, to explore, and to dream. The quest to understand it, and countless other enigmas, is the great adventure of our time. If you're captivated, please like and subscribe to Cosmic Discover. Together we can continue to explore these wonders.